what I would like you to do right now in front of you on a blue piece of paper are what I want to call my essential questions for today. These are the 3 things that I think when we're done, we should be able to answer. What I would like you to do right now as a table group, I don't want you to write anything yet. I don't want you to write anything yet. I want you to just read the questions to yourself and then talk as a table group what you think the possible answers might be to these questions. Would you do that for me? Take about 2 minutes and talk with your table group about that.
I'm just going to be over here because I want to be messing around with English, please. What?
That's a good one. I really have no idea what it is.
Discussion in 5, 4, 3, 2, 1. Excellent. I wanted you to get a chance to say that last statement that you had out. This is the things that we're going to be focusing on today. One word that I heard being said, it's a new vocabulary, and we'll talk about it in a minute, but when you say it, I want you to say it correctly. And this is the word integers. Integers, not integers. Integers. It doesn't make a lion-ger sound. Okay? So turn to your partner and say integers. 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 Excellent. When we learn the vocabulary, we'll be talking about what it means. Good. Integers. Nice soft G. What I want you to do now, in your bag in front of you with your algebra tiles, listen carefully for instructions. You kind of see that there's a lot of different shapes in there, right? I only want you to pull out the little teeny tiny squares. Leave the rest inside the bag, just the teeny tiny squares that are in there. The rest, you can look at the other ones real quick. Just kind of look at them, then put them back. You can dump them all out to get all of them out. And then put the big, long, skinny ones and the big, giant ones back in the bag. We'll get to those another time. You can look at them real quick, like, these are interesting. Okay, turn and look at me, please. Hands off your tiles. It's hard, unless you're putting them back in the bag to finish them. Jeremiah, we with me? Thank you. Bryson? We'll talk about that. One of the things I'm going to have you do, you're going to be looking and messing around with these tiles in a minute, but the play that is not acceptable, first of all, is putting a tile in any body part. Please don't. It doesn't go in your ear, in your nose, in your mouth. Please don't. They don't have a taste. Trust me. Okay? The other thing is, please don't do tiddlywinks where you focus one on another and then push it, because they go flying and they are very, very hard to find. You don't think red and yellow would camouflage itself well, but it does. And we will lose them, and they're pretty expensive, so I'd appreciate it if you don't do that. But as far as that, you can stack, you can move, you can, mess around with them a little bit. But what I want you to be doing as you're playing with them, get your play out now, because this is your chance. After this, we're not playing anymore. You have about 2 minutes to play and make patterns, do whatever. I want you to be looking for, I don't know, see what you notice. Go for it. Play a little bit. See what you notice. Thank you. I know that Zach was talking about what he noticed. Did you guys talk about what you noticed?
I noticed it's 9 millimeters long. Each one of them.
Okay.
Is exactly 9 millimeters.
Keep looking. Keep looking. There's more. Nice. Keep looking. Caitlin, what do you notice? Have you been noticing any? They are. Are you a 49er fan? Nice. Okay, you have about 10 seconds to finish play, and then after this, if I see playing going on, no more tiles for you. So you'll have to do everything by just watching. And I know you won't want to do that because you'll want to play with the tiles. Usually it helps if you can just play and get it out of your system right now. Make your flower, check out the patterns you can make, tower them up, that's about it.
I don't know if I can turn these into a circle.
It is tricky. It is tricky.
There we go.
Okay, you have 5, 4, 3, 2, 1. Thank you, Dylan. Awesome. Thank you. Thank you in the back table. Still waiting for Alexa. Thank you. Tell me, without touching your tiles, this is the hardest thing. Sometimes it's good to just move them away from your hands because it's hard not to fiddle with them. Can I have some volunteers to tell me, what did you notice about these tiles? What did you notice about these tiles? Okay, Sydney, what did you notice?
They're square.
They are squares. They are perfect squares. This is really important. That may seem like, well, duh. It's really, really important to what we're doing. Excellent observation. Zach, what did you notice?
I noticed they're roughly a centimeter square.
Yeah, they're about a centimeter by a centimeter. Pretty close. Good measurements there. Dylan.
One side's one color, one side's the other.
One side's red, one side's yellow. If you kind of look in your bag, is there another one that's yellow and red? No, yellow and red. But I do notice that, Bryson, what were you going to say about the color? I just heard you say it out loud, so I'm going to ask you to say it out loud again.
There's a blue and a red one.
There's blue and red,
There's a red and a green.
and there's a red and a green, and then there's a red and a yellow.
They already have, they all have red.
All of them have red on them, one side. Good observation. Good one. Rennie, what do you notice?
That they're all 90 degrees.
Yeah, they have to be perfect squares, so they all have to be 90-degree angle. Jeremiah, what did you notice?
Each side's 9 millimeters long.
Yeah, he went for the more specific and said exactly 9 millimeters. Close to a centimeter would be 10, but about right there. Paloma?
Put them all together, you can make one big square.
Nice. You can use them to make other shapes. Can we make a rectangle?
Yeah.
Excellent. Good. So we can make a square, we can make a rectangle. Go ahead, James.
You can make a very rough circle with little pointy edges.
Yeah, you can turn them sideways and make a circle out of them. Zach?
I think that all of these together in a 5 by 5 square equal one of the big ones.
Ooh, you are so driving where we're going to get the next time we're out. I love that you're thinking about that. That is awesome. So did someone kind of think of that too? They're like, ooh, they're almost about the same. Paloma?
Some of them, if they're all just one by a few of them, you can make one of the big ones.
Yeah, you absolutely can. It looks that way. Ladies? Thank you. All right, a couple things you need to notice about mine. First of all, the yellow is a little hard to see, but we'll live with it, right? If I use regular tiles up on here, you can't see the colors at all. Mine are one-sided, but they're supposed to look like yours because they were meant for one of those overheads that shines the light through. Do you know what I'm talking about? They're meant for the overhead. So mine are only one-sided, but I'm pretending like when I turn this one over, I get this one. We okay with that? So you'll see me do that. Like, look, I'll flip it over. Ah. So mine is not as cool as yours, but it'll work anyway. Okay? All right. One of the things I want you to look at and think about, we're going to change our thinking about what these tiles are. You said they were squares, which is fine. This little square right here is going to represent a 1 by 1. So I'm going to pull on Zach's thought that they're 1 centimeter. It's a 1 by 1 square. So we're going to call it a unit, a 1 unit. Are we okay with that? Okay, so this is 1 unit right here. So if the yellow is 1 unit, what is the red? Aiden? It is. It's the opposite of 1 unit. Because if you flip it over, isn't that the opposite? Okay, so flip it over and let's look at the red.
The red is 1 unit, then the yellow would be a negative.
That's a good one. I'm going to hold that question, okay? Because we're going to talk about that one. Love that you thought of that. So she says, why isn't the red the 1 unit and the yellow the opposite? We're going to get to that one eventually. Good point. Because what did we notice about all the tiles in the bag? That they all have red on them. That might lead us to something eventually later on. Okay, so this is my 1 unit, and the other side is the opposite side. So the opposite is going to be negative. Okay? So this collection of numbers, positive, negative numbers, are called integers. Integers. It's a group way for us to say all positive numbers and all negative numbers. However, it's not all numbers. 1/2 is not an integer. 3.2 is not an integer. So what's an integer? -5 is an integer. -7.8 is not an integer.
I know.
Okay, think about it for a second. Kaylin, what do you think? They have to be the whole number. No fractions, no decimals, nothing like that. It has to be just the actual number and it's negative. Well, that makes sense because what is 1.2 of this little tiny yellow thing? Zach, you want to give me a thought?
2 millimeters.
Yeah, it'll be like shaved off the edge. Well, because you don't have X-Acto knives, we're not doing that. So we're going to stay with integers. So integers are positive and negative numbers. They have to be whole numbers. Would you turn to your shoulder partner and say, integers are, and tell them what they are. Okay, come back. If you look at the yellow sheet that I gave you on your table, this is your note maker for today. We're going to be making some notes at the top. The first side says, how do you model adding and subtracting integers using algebra tiles? That's at the top. This is our target for today. We're going to be able to figure out how to do this. You kind of look at the note maker a little bit, get yourself familiar with it. On the left is going to be asking for some picture drawing. Please don't do that now. We're going to do that when we work with the tiles. But on the right-hand side, it says, describe all the vocabulary words and what they mean. Can you put your finger where I'm talking about so you know what I'm talking about? Thank you very much. Okay, describe all vocabulary words and what they mean. You can now describe integers. Would you do that for yourself in your words? Oh, good. A whole number, positive or negative. Excellent. That's a nice way to phrase it. Okay, what do we think about the word opposite? How does that have anything to do with what we're talking about today? With integers, why would opposite matter? Give it for a second. Rini, why do opposite matter?
Because the negative is opposite of the positive.
Very good. And positive is the
Opposite of the negative.
awesome. Okay, so opposite, the reason why we're talking about opposite is another word for negative. Okay, when you talk about the negative of something, you're talking about the opposite. Or positive is the opposite of negative, negative is the opposite of positive. Can you write something for yourself under opposite? Why we would talk about opposites with integers? It's either the negatives are opposite of the positives, or positives are opposite of negatives, something like that. Can you share with your shoulder partner what you just wrote, please? Kaylin, would you share with Chrissy? That's okay. You can add to it if you like what your partner had to say. That's a good idea. Okay, the next word that's on your list, thank you for discussing that with your shoulder partner for me. The next word on your list is called additive inverse. Say it with me. Additive inverse. Additive inverse. By pulling apart that word, those two words, what do you think that means? Yes, ma'am.
If you add negative and positive, it will equal 0.
Ooh, I like that. If you add negative and positive, it'll equal 0. Keep adding. Zach, what do you think?
I think it's like the additive means like adding with one, and inverse is like you could use that same concept with the red side of the tiles.
Ooh. You even added the tiles in on that. That's excellent. Additive inverse. What does normally the word inverse mean? You can say it out loud. We don't know what inverse is. Opposite. Yeah, it's another word for opposite. Inverse is another word for opposite. Or to undo. Inverse is another word for undo. Okay? So additive. Additive means what? Big guess. Add. Woo, yeah, that's a tricky word. So we're adding opposite. Adding opposite. Do you hear those words in there? Or undoing adding. Jeremiah, are you playing? Hope not. All right, so when I look at my additive inverse, let's come up here with my tiles. I need to see eyes here so I know. Aiden, thank you. If I add 2 to something, what's the additive inverse? Read.
It's subtracting 2.
It's subtracting 2. So if I add 2 yellows, I need to, the opposite would be to add 2 reds. Additive inverse is like if I dig a hole, what's the opposite? Putting the dirt back in. If I give you $5, what's the opposite? Go ahead and say it out, Bryson. Take $5 away. So if I give him 5, I have to take 5. If I dig a hole, I got to fill it in. If I put in 2 yellows, if I want the additive inverse, I need to bring in 2 reds. Okay? Tell me where you are right now. Thumbs up, I know what you're saying. I got the additive inverse, not a problem. Not quite sure what you're saying, a sideways thumb. Down is, can you say that again, please? One hand, please, so I know which one. I totally got what you're saying. Kind of. No idea. Okay. Excellent. Yes, it can be. Okay, I noticed that there's only a couple people that are a little shaky on it. Additive inverse means if I'm going to bring in, let's say I'm going to bring in, we'll try one more example. I have 3 yellows. What's the additive inverse of 3 yellows? 3 reds. Or taking away 3 yellows is another way to do it. But when I want to show an actual model, I'm bringing in the 3 yellows, I'm going to have to bring in the 3 reds. When you do that, when you bring in a yellow and a red and you put them together like this, what does that equal? What does add 1 minus 1 equal? Just going to model it up here. I think some of you, show me on your hands. Show me your answer. There you go. It's 0. So if I add 2 and subtract 2, these, what happens here is they end up pairing up, don't they? And what are these opposite color pairs? What do they add to? 0. So an opposite pair is a 0. An additive inverse will give you 0. The result is always 0. Okay? And it doesn't seem like a big deal, but it's going to be a big deal in a little bit. Okay? Would you write down something for additive inverse? Add the opposite. You can think about it that way. If you bring in 2, you have to bring in negative 2 or minus 2. If you give 2, you have to take away 2. But the result is always what? 0. Awesome. Make sure you have that. And sometimes it helps when you write to yourself if you give yourself an example. Plus 2, minus 2 gives me 0. I'm going to tell you a little story about a place called Integer Continent. Bryson, are you with me? Thank you. A little story about Integer Continent. What's a continent? Help me out. Say it out loud.
Piece of land.
Piece of land. Yeah, country, piece of land, Integer Continent. 2 kinds of people on Integer Continent. The happy people. People that are positive. You know those kind of people. Oh, it's such a beautiful day. I love soccer. I love baseball. I love the color black. I love your hair. It's such a great day. I love pretzels. Yum. Everything is good. I love going to music. I love computers. I love math. Woo. Okay, positive people, right? We have those kind of people. And there's another type of person. You know the type of person. Negative people. I hate that. It's cold outside. I don't like when the leaves turn. They're always falling. It makes crunchy sounds. I don't like crunchy sounds. I don't like pretzels. They're too salty. Yes. I don't like going to music. It's too loud. I hate today. We know these kind of people, don't we? The glass is half empty. Yes, we know those kind of people. Okay, so you mix those kind of people together. What happens when you mix positive and negative people together all the time? Optimistic and pessimistic people. Yes, it is scary. It's nice. No, it's not. It's hot. It's too cold. And they're always fighting each other. This is what happened in Integer Continent. For a while, the people lived peacefully. Didn't last very long. Positive people like to be around positive people. Negative people like to complain together. Okay? So what happened is they just decided we need to be away from each other. Positive people moved to the right of the continent. Negative people moved to the left. Okay? Positive people moved to the right side. It's a little bit easier. It's a little bit happier over there. Negative people move to the yucky side, which they think so. Yes, ma'am?
But if they were all together, like, just do
You'd think. But if you ever meet people, they never agree to disagree. You know that. They just got to keep fighting it out. You know, it's happy, it's sad, it's good, it's bad. So they just decided they just couldn't get along. The problem is, you know what happened when people live in an area together? What do they end up doing eventually?
fight.
Yes, I want your land, you want my land. So they decide to fight. Yes, ma'am?
If they're always positive, if the people are always positive, then wouldn't they just be positive if they could be around negative people?
You'd think they'd be able to balance it out, but human beings are not very good that way, if you notice that. Positive people sometimes get dragged down. Well, some of us. Renee, yes?
What happens to this land.
Yeah, they don't sing that there. It's a very strange place. Okay, so they decide they're going to fight. They want each other's land. They're going to fight. They're going to fight. But these people are not too bright, obviously, because they should be able to just get along. Jeremiah, thank you. So they should be able to just get along, but they don't. So they decide they're going to fight. How do they fight? Like the Revolutionary War. So what does that mean? They come and they all line up, right? They march out. They march out. They line up. They line up across from each other. They have their guns, right? They get there. Person says, ready, aim, shoot, and they all shoot. Which is actually, if you think about it, a very dumb way to fight. Which is true. And so why did they fight like that for hundreds of years? Who knows? But they fight like that, so they line up. So what happens is if you're lined up across from someone and you both shoot at the same time, what happens? Yeah, you're both done. Okay? And someone else has to come up and take your place. So basically, in theory, who will win?
No one.
Someone will win.
The neutral.
The one with the most people, right? You want the one with the most people. This is how these people have operated for millions of years. So we can model that right here, and you can model that with your tiles right now. So let's march out. We need to march out about, 5 yellow folks, 5 positive, happy people. Here they come. March them out in a line. There they are. Thank you for your march music. I appreciate it. Yep, get them hop-toing. They need to be ready in their line. Do you have 5 people in a line? Yellow people, the positive people, happy people. Excellent. Look up here for 1 second, soldiers. Aiden, up here. Nicole, here. Why didn't I have to write +5? Yellow is 5, but why didn't I have to write +5? Chrissy?
It's always positive if you don't have a
That's right. It's understood. So we understand that these guys are going to be positive, okay? However, if I want to show a negative person, do I have to put the negative sign? Yeah, somehow, okay? Because otherwise you don't know. Okay, so I have my 5 people marched out. Okay, and let's see. Let's get our negative army out. How many negative armies are going to be out there? 3. How do I know there's 3? Because it says -3. It also says -3. Okay, so they march them out. Here they are on the battlefield. Do you have your battlefields ready? Okay, they're lined up across from each other. What happens? Ready, aim, fire. Do you see what happens at this guy, and this guy shoot each other? And they're all gone. That is correct. Tell me, besides the soldier story, what's happening with the yellow and the red pairing up?
It won't get obliterated.
Use your vocabulary that I taught you so far. What?
The 2 integers.
Integers.
Integers are lining up against each other, and they're both getting rid of each other.
Because they are what?
Because they're opposites, they'll pair up and turn into a neutral.
They are opposites. Aiden, can you use the vocabulary?
Yes, they're adding inverse.
They're additive inverse. What does a positive 1 and a negative 1 make? Tell me, everyone. What is a positive 1? 0. Very good. So this is really 0. If you all shoot each other, you're 0, right? So that's gone. This is gone, and this is gone. And what's left?
2 happy people.
You guys should know this, right? What's 5 take away 3? 2. Okay. But still, it matters who had the most. Who had the most this time? Positive people. Very good. Okay. Ready to model another one? It means you have to model them marching out right next to each other. Okay, so we have our -2 army. Here they come. Thank you for sound effects. Then what about this one? What is this one? Okay, we're marching out. We march out to the battlefield. The smoke clears, and are you staring at your own army back at you? Aren't the reds all on the same side? They're not going to shoot each other. They need the people. You're going to be like, ready, set, wait, that's our guys. You're not going to shoot each other. Is there an additive inverse there? No. So what's going to happen? They're going to get over here. What are you doing over there? Get over here, and this is who we have. So tell me, What's the end result? Aiden? Negative 6 is correct. So when you take a negative 2, look up here. When you take a negative 2 and add a negative 4, you end up with a negative 6. Why? Because you have 2 reds and 4 more reds. They're going to join together. They are not going to fight. Okay? All right. Let's try another one. This is always the tricky one. Oh, so tricky, parentheses. Is that tricky? No. Oh, big deal. Model it for me on your paper. Let me see it. March them up. I need to see marchage. March it up. You and your shoulder partner need to be looking at each other when you're doing this and say, are you doing this right? Then tell each other what the answer is. What happens when you take negative 3 and add negative 2?
Meanwhile, the Shenandoah Valley goes on in the distance.
We were still on that last problem.
Were we okay?
I don't get where
But
he
meanwhile,
comes
a different battle goes on.
I thought we were still on the last problem.
But they shoot each other this afternoon.
Could be. Tell me what your final result is. Negative what?
5.
Negative 5. Okay. All right, let's do, I want to see it modeled out with your algebra tiles, and then I'm going to ask someone to come up and model it for me up here. So if I see you modeling it really well, and I want a final result as well. So if I see you model it pretty well, I might ask you to come up and model it for me on the board. So what do you need to put out there? What is Paloma putting out? Okay. Does it matter that she's doing the positives first? Can't really tell, can you? They're lined up. It doesn't really matter which line is, which side of the field they're on. The shooting will happen either way. Anyone know what property that's called? Anybody know what property that is, that you can take numbers and rearrange them and not change the result of the problem? It's called the commutative property. You can change addition around. It's good. Okay, so there we go. She's got her negative 5 and her positive 8. And there. What are those called when she's starting to do that? Additive inverse. That's additive inverse. There's 0 pairs. Very good. There goes 0 pair. There goes 0 pair. And who is going to win?
Positive.
Positive 3. Positive 3. Very good. Oops. Okay, positive 3. Here's another one for you. Model. All right, let's take a look. I see a lot of common mistakes going on. First of all, we need to model what we have. What is this? 2 what color? 2 yellow, right? There's 2 positives, so we start with my 2. What is the next number? Positive 4? It's negative 4. Subtraction and opposite and negative are all the same. Subtraction is takeaway. Subtraction is the opposite of addition. Opposite, so it's negative. So that one, it's going to look like this to start off with. There's the lineup. 2 and negative 4. 2 and negative 4. Okay, it's really an addition problem, isn't it? What's another way I could write this to make it look like an addition problem? Read.
You could go -4 plus 2.
Oh, I could. -4 plus 2. Excellent. What's another way I could do it? Leaving the 2 first. Matt?
Plus 2 plus
-4.
parentheses -4.
Good. You can do a parenthesis. Another way to do it? Chrissy?
-2 plus 4.
Is that the same thing? He's like, whoops. No, when I said it. Read. Go ahead.
2 plus -4.
Good. You don't even need the parentheses if you don't want to. But all of those are the exact same problem. Weird. A subtraction problem can be an addition problem because subtraction is just opposite. Okay? So if I have my 2 here and I have my -4, what's going to happen? What happens to my guys?
Positive.
Yep, there's my additive inverse, my 0 pairs. What is the final answer? -2, -2. For every single one of them, it's -2. That's kind of weird. Here's another problem for you. Can you model it, please? Model it. Yeah, that 4 is up there. And then he brings up a 1 red, because that was -1. And then that is an additive inverse, 0 pair, and the answer is 3. Okay. What I would like you to do right now, on the right side of your paper where it says examples from how we're hitting our target, can you please draw this one right here? I'm going to grab it in a different color. This example and this example, and you can draw them with boxes shaded in. So one of the ways that I draw my boxes, this is my red. I do this for red and this for yellow. Okay, because it's really hard to get yellow and red on your paper. So if you would do that for me, if you would put these 2 circled in orange examples, and we need to make sure that we write the final answer, what it looks like. You want to put that on your note maker. It's in the right-hand side where it says examples on how to reach the target from above. Excellent, good. That's in the right spot, man. You're right. Yep, I'm right here. Okay, there's a new problem up. All I want you to see is modeling. All I want to see is modeling right now. This is the problem. Right here. Here's the problem right here. Can you start modeling it with tiles? And I'm going to have Matt go up and model it for me. So Matt decides it needs to start with 2 negatives. Did we start that far? 2 negative, 2 red. Okay. And then he said now it needs a, very good. The next one's negative. It says -3. It's a negative. There are 3 negatives there. If it says -3, it's the same thing as saying plus -3. All right, and so my final answer will be, Matt?
-5.
Yeah, they are all on the same side. They're not going to shoot each other. Excellent. Good job. So it's going to be -5. Thank you, sir. Would you look at the top? It's right here on your yellow sheet. Right here. It says, what do you do when they have the same sign? What do you do when they have the same sign? So what happens when they have the same sign? What are we doing to these numbers? Aiden? We're just adding them, aren't we? But did -2 minus 3 become 5? No, what is it? -5. How come it's not just 5 if we add them? Kaylin, say it again. Because they're both negative, so the answer has to be negative. If they were both positive, the answer would have to be positive. That's right. Read, question?
Also, if they're both negatives, they could also be, since sometimes if there's no sign and they're just right next to each other, since they're both just negatives, they might be multiplying by each other.
And we'll be talking about that one soon. You're right. You're right. But in this case, they're not actually sitting next to each other. The minus sign is in between. So right now, up on the top left, what happens when you add integers with the same sign? You actually add the numbers, but you have to do what with the sign? The positive and negative. What do you have to do with it? Chrissy? Keep it. So we add the numbers and keep the sign. You might want to show yourself with this example right here. So would you please make sure that example is up there to help you? The next one down on that, in that note maker, the first one says if they have the same sign. The second one says draw a picture to show additive inverse. How do you draw a picture to show additive inverse? You can show 2 negatives and 2 positives. 2 negatives, 2 positives become what? 0. You can do 1 positive, 1 negative to make it really easy, but the answer is going to be 0. Right next below. See where it's number 2? Okay. You're going to show with tiles how to get the additive inverse. So it's going to be a shaded square and an open square. They become 0. 2 shaded squares or 2 open squares. However you want to show additive inverse. Sit. You put that down. So show yourself with manipulatives. Perfect. Good job, Noah. That's exactly it. Excellent. Right here. That they become 0 pairs. You can also write the word 0 pairs. Really helpful. Excellent. Good job, Noah. Yes, and they become what? Yeah, you can add the shooting and whatever it is you want to add. Yes, right here. You can add whatever it is you want to add to show that they are opposites of each other. I want you to get used to that. That's going to be really important when we bump this up to algebra. Okay? That leaves us with number 3, right? How to add integers with different signs. What are integers again? Whole numbers and their Positives and negatives. Whole numbers and their opposites. Good. Okay, so what are we going to do when the signs are different? Okay. Okay, let's get our, write this down there, please, where it says, what do you do when the signs are different? Because these are different signs, right? There's a negative, there's a positive. Negative and a positive. Okay. So negative, write -4 plus 2. Jeremiah, write with me, please. Thank you. On number 3. Bryson, are you with me? How do I model -4? 4 reds. Excellent. Sorry. Thank you, Chrissy, for raising your hand. I appreciate that. 4 reds. How do I model +2? Anyone? 2 yellows. Very good. So and you need to draw these. So you're going to have your 4 shaded, your 2 open. Your 4 shaded, your 2 open. So you're drawing this time. You can model it with your hands too if you want to with your tiles, but I want you to draw it as well. So draw what it's going to look like. Right there, Rennie Ray. You can do it with your tiles first, but then I do want you to draw it on here. Oh, that's good. Why do I like that you did the red like that? Okay, so you have this drawing right here. So what happens? What happens with them lined up across from each other like that? Aiden? Right, so you can circle your pairs and put a cross through them to show that they're moving out, Kaylin, right? You can put a circle through them and put an X through them. Yeah? And you have the 2 leftover negatives. So the question is, what do we do when our integers have different signs? How do you add or subtract them? How do you do it? What keeps happening every single time? Why don't you turn right now, you and your shoulder partner talk about that. What's happening every single time we're adding something with different signs? Okay, so here's my question. If you've had this discussion now and you think you've figured out what the whole pattern is, I put up 3 additional problems underneath. Does your pattern work for all of them? I even put the answer. So whatever pattern you came up with, if it doesn't work for one of them, you need to rethink what you're going to say. And go ahead and write it down there under number 3. See if you can figure out what you have to be decided on what it is you want to say. Okay, but make sure it works for every single one of those problems, because I heard some great stuff, but then I went, wait, that wouldn't work for some of those. So think about it. How do you add things with different signs? All 3 of those below have different signs. Talk about it, make sure, and then see if you guys can write it down for yourselves. What is the pattern? There are 2 things you have to worry about, aren't there? There's the sign of the answer. Is it positive or negative? And then there's the number in the answer, right? So there's 2 things you have to be worried about. So I heard over in here a really good suggestion on how to get the sign. This. Whether it's positive or negative. So Dylan and Matt, either one of you want to explain how you get that?
You look at the greatest number of the 2 before, not the answer. The answer doesn't matter at this point.
Right, just these.
So the greater number, its sign is going to be the sign at the end.
Okay, so let's check his pattern. Great.
Have, let's say the -6 there. That's the greater one. 6 is greater, so it is going to end up to be. It really is -6. It isn't just. It isn't +6. It's -6 because you have the minus sign there. So it's going to end up being a negative.
3 and 5 and 3 and -5. This isn't +5. 3 and -5. Negative's bigger. Negative answer. -2 and 7. 7's bigger. Positive answer. Are we okay with that? Did you guys come up with that? Sort of, kind of, did you sort of figure that out? Okay, that's the sign. How do you get the number? How do you get the number? Ben, I haven't heard from you.
You subtract the lower number from the higher number.
Yeah, you basically just subtract them, and it doesn't really matter. 6 minus 4, 2. 5 minus 3, 2. 7 minus 2, 5. But the sign is what matters, right? So if they have different signs, you're going to be subtracting, aren't you? If they have the same sign, what did you decide we had to do? Elizabeth? Add. So that's kind of weird. It's like the problem, it doesn't matter if it looks like a subtraction problem, because this looks like a subtraction problem, doesn't it? Looks like take away 3, right? But it doesn't matter what they look like. This looks like an addition problem. This looks like a subtraction, addition. But that's not really what they are they? This one turns out to be an addition problem. This one is a subtraction problem. That's kind of strange, huh? A little bit. It challenges what you think. However, if you get confused, what can you do? What can you draw for yourself if you get confused? Read.
Here's an example, like.
Okay, wait, you didn't answer my question.
Well,
I know you're
okay.
going. I'm gonna ask for your example in 1 second.
Here's,
Oh, okay.
you could draw like football players, one
There you
team
go.
is one color, one team's the other color.
Absolutely.
They could, these guys could, well, they can do, 2 guys, so let's say 2 and 7.
Mhm.
So
You
I'll
can
get
draw, you can draw algebra tiles, is right. You can draw football players. You can draw.
And then so see this, they're like pretty much trapped because these guys can't go through it. But press to one of these guys.
You got the offensive line down pat right there, and the defensive line backing them. Aiden, you can draw algebra tiles. Are you gonna say that?
However many chances for touchdown.
Yeah. This is what I notice a lot of students do. We'll do this. Pluses and minuses, because they're fast to draw, right? And then you know that you can just go, that's done, and then I have what's left. You can do smiley faces and sad faces, whatever, circles and a line if you want to. But something that gives you like, wait, how does this work again? Because if I asked you to do negative 1.7, are you ready? If I asked you to do these, you can't use algebra tiles anymore. You're done. Algebra tiles, we're not using our X-Acto knives on them. So if I want to do a problem like that, I'm going to have to think in my head, what exactly am I doing? Are they the same sign, yes or no? No. Who's bigger? Who's bigger? Yeah, this one is bigger. 1.7. 1 and 7/10 is bigger than just 7/10. This one's bigger. So what will the sign of my answer be? Go ahead, Nadia. It'll be negative because this guy is bigger. What am I going to do if these signs are different from each other? You guys said we were going to have to do what? Okay. Subtract. What is 1.7 minus 0.7? 1. Good. So it'll be negative 1.0. So you can go back to thinking about our process, but you can also go back and draw little parts if you need to. Okay? Are we okay with that? We understand how that works? Would you take a moment at the bottom, explain how to add and subtract? Just give yourself a one more time, say it out for yourself. How do you do it? And I know a lot of you have already written it. Thank you very much. And then there's a little flashcard at the bottom. Make up 2 problems without using tiles that you can ask somebody else. So make up 2 problems, if you will, and write the little summary for yourself. How do you add and subtract? I'm going to give you a minute to sort of get that done, and we'll do a little flashcard. You have an orange sheet on your desk? How many of you have ever done a brainstorm before? Nice. It just means you can put down anything you want, circling it off. As a table group, I would like you to try to get that as full as you can. How many ways can you say what you see in front of you? I'm not going to say it. So put lines off of it and start writing in as much as you can think of. You can even do it as a list if you're more comfortable as a list.
Just use a bunch of different accents.
Keep going. How many ways can you do that? Think of as many as you can. Brainstorm as a table group. And write them down. Use some words. I need to see some words too, not just numbers. Oh, like this? Like that? Yeah, it's true. Go ahead, James.
-7 and normal, and say that. +1.
Yeah, -6. And you could do all kinds of little problems. So we'll contain that as our problem holder We'll leave the problems. How many other ways can you say it in words? How many other ways can you say -6? There was one on your note maker. Let's see if you can figure it out. Rennie? It's not the same as -6. Give me -6.0.
You have it at decimal.
Mm-hmm. You can add the decimal and you can add as many zeros as you want. That'll work. We'll consider that the whole zero placeholder spot. Good job, Reed. What ways can you say it in words? It was on your note maker in yellow somewhere. What other way can you say -6? Besides a problem, in words. James?
Oh, wait, memory.
Brittany?
Additive inverses.
Additive inverse of 6 would be +6, but you're getting so warm. Aiden? Yeah, the language of mathematics. I'm going to contain you there. Yes, ma'am. Nicole. No, it's not Nicole. I'm sorry. Alexa. Thank you. I just lost it. Integer. So it is an integer. So which integer is it? -6. So we got to figure out which ways can we say it. Paloma? Opposite of 6. Very good. The opposite of 6. What's another way? There's more. Not in Spanish. What is it? Seis? My bad. Read.
I'm thinking maybe like negative, the opposite of 6.0.
Yeah, this one. The opposite of 6.0 is good. What about if I said subtract 6? Isn't that the same thing? Uh-oh. So if I say...
It is 0 minus 6.
0 minus... It's a problem. So that goes up here. Same thing, because it's up in the problems. I can call it subtract 6. Give me some other ways I could say subtract. And you'll be able to figure out all the ways I'm looking at. Yes, ma'am? -6. Great. We can call it -6. What other things can we call it? Keep adding these. If you don't have them, you need to write them down. Read.
Erase 6.
So what's another word for erase? I'm going to use that one here. Delete. There's another one, the real big major one we talk about with subtraction.
Take away.
Take away. That's a huge one. Take away 6. Do you see that if I have this in a problem? Oh, Aiden has another one.
If you take away 12 from
So in the problem section, right? So you do 12. Yeah. -12 plus 6. That would be in the problem section. But look at these. Opposite, negative, subtract, minus, erase, delete, take away. Every time you hear that, we're talking about a negative number. Every time you hear that. So how would I say this then? That's tricky. How would I say that in words? In words. Yes, ma'am. How would I say it in words as I'm going? Kaylin? 3 minus -2. Give me another way to say it. Perfect. That was great, Kaylin. 3 minus -2. Rennie, give me another one.
3 take away -2.
Uh-huh. 3 take away -2. What happens when you take away a negative?
You add one.
You add it. Isn't taking away a negative a positive? If I say take it away, and then you're like, okay. Yeah, minus, it means take away. So what happens when you take away a negative? What do you get? A positive. That's weird. Here's another way to look at that.
You get, I know
Go ahead,
the
Reed.
way to say it.
Go ahead and say it, kid.
1, the answer.
Is the 1 the answer?
Yeah.
Okay,
3
here's...
minus -2.
Let's start it out like this. 3 minus -2. Let's put up the 3. Get your tiles. Let's put the 3. Get your tiles and put out +3. And let's put out our -2. Does everyone with tiles have their +3 and -2? James, there's one down by your chair, kiddo. I don't know if you noticed it fell. Does everybody have a 3 yellow and a 2 red? Orlando, do you have it? 3 yellow, 2 red. Modeled. I see Paloma's good. I see Zach's good. Okay, so here's the deal. Look up here at mine. Look up at mine, please, for a second. You already have yours out, so look up at mine for a second. This is 3 and -2, right? But it said 3 take away -2. So what happens there, or 3 and the opposite. Oh, whoa. 3 and the opposite of -2. What's the opposite of -2? +2, right? So you'd flip your -2 over, and there they are. So it becomes 3 and a +2. So what does my answer end up turning out to be? +5, isn't it? These are like, if you're talking about integer content and you're talking about warfare, these are like double agents. You don't really know which team they're for when they show up. They look like natives, but it's the opposite. It's like they're spies, right? So you kind of look at that and you're like, oh, the spy, oh, you have to turn them over because it's the opposite of negative, or take away the negative. Dylan.
I remember learning this quite a while ago. If you have two negatives like this, you put them together and you have a positive.
But, and that's right, in a way. But one of the things I want to make sure is you understand why. It's not a trick. It's not a trick, is it? If you use the words 3, take away the -2. 3, take away a negative. So if you use the words, you'll understand why it happens. We got it? You ready to try some? Try some with your tiles. Model with the tiles, and I really want you to think about what it means to say take away the opposite. Take away the opposite, minus negative. Those are all meaning the same thing in words. But in tiles, it means double agent, because you mean the opposite of the negative. Check with your shoulder partner and see if you both have the answers to these right here. Check with them. What did you guys get? What did you get for this one? What did you get for that one? There we go. Let's start with, it's -3. So we start with our -3, and if you want to model it to get it for yourself in your head, -3, and then there was a -1 out there showing up. But this problem says right here, we're going to take away the negative. So this -1 is a double agent. It's going to flip itself over. Take away the negative means to make them positive. So right now I have 3 negatives and 1 positive. Are they the same sign or different? Same sign or different? They're different signs. One's negative, one's positive. Which one has more? The negative or positive guy? The negative guy. So that means my answer has to be negative. What do I do with these two numbers? Subtract. Good, because they're different signs. So it'll be -2. And that would happen because there's the additive inverse and it's gone, and it's going to be -2. Sounds tricky. 4 minus -2. I end up with my 4. And then inside the parentheses, I have my -2. I have my 4 and my -2. Read, stay with me. And then this says, whoa, double agent, take away the negative. I'm going to flip these up. And what do I have finally? What am I going to do? Are they the same sign? Yep. So what do you do when they're the same sign? Add them and keep the sign. So it'll be +6. Okay? Would you add one of these examples right here on your target sheet? There's a spot for examples. Would you add one of those that had a negative? I'll put some up if you want to try one yourself and add it on if you want to. So I'll add some different ones. Please remember the opposite of a negative. The opposite of a negative is a positive. There, kiddo, is where I want the examples. There you go, Sydney, right in there. Good. You need to have these really well filled out because we'll be looking back again at these when we move to the algebra portion. But you have to know integers before you can do the algebra. People are asking me, how do you draw this? How do you draw that they flipped over? That sometimes is kind of hard to do. So if I did this first one, I would draw my 4, and then it says -3, so I would have them like this. 4 minus -3, and then I would like this would, and I just put my arrow like that, and I would just circle them all to flip them over. So I'd flip them over like this. And now it's 4 plus +3, isn't it? And then I now have 7. So that's how I draw it. I draw that I circle them. That helps me. But if you have a way that makes sense to you, then please feel free to keep it. Would you add your second problem to your flashcard at the bottom? And you can use one of these doubles. See if you can really come up with something that's an interesting one. Try to use the double, if you can, the double subtraction or the takeaway or the opposite of negative. So we can use any of those words, whichever word makes sense to you. Are we ready? Grab your sheet of paper, your yellow sheet, please. Make sure your algebra tiles are not stuck to it somewhere. I would like you to ask someone that is not sitting anywhere near you. I want you to show them the flashcard and see if they can give you the answers, and you discuss it. So please stand up, find someone else. Do the flashcard. Come on, Jeremiah. You got to find someone else. We've talked about this one, all right. How do you model adding and subtracting integers using algebra tiles? We okay right there so far? We're still going to have to practice it. Not some of you, ooh, I made a couple of mistakes. Can you model the additive inverse using tiles? Yeah. How do you do that? It was like positive, negative. 1, 1, and they're gone, right? We have that? Okay. This next one is multiplying and dividing integers. This is the next one we're going to be talking about, because we need to be able to do this to move on to our algebra. What is that? 2 times 3. That's one way to say it. What's another way? 6. That's true. What's another way to say it? James?
2 multiplied by 3.
Mm-hmm. Read, another way?
6.0.
That's true. Yes?
2 by 3.
2 by 3. Excellent. 2 sets of 3. Do you agree with that?
Yes.
2 sets of 3. Bryson, what do you say? 3 twice. Excellent. So with your tiles, would you give me 2 sets of 3? Are these positive or negative numbers I have up there? Yeah, so should I be seeing red tiles? No, I should be seeing yellow tiles. 2 sets of 3. 2 sets of 3. Brady, how you doing, kiddo? You good? Okay. All right. Do you have what I have sort of up on my board? Right here. If you have red, you're doing something off. Okay, do you have yellow? I'm going to use Brittany's idea, because that's what I want to guide us right now. 2 by 3. So let's squish them together and make it a rectangle. Just so you know, multiplication can all be done with rectangles. Multiplication is what area comes from, right? If I ask you to find the area of this rectangle, how do you do it? Kaylin? Yeah, you do 2 times 3, don't you? You can always count them. That's totally appropriate as well. But it's a 2 by 3 rectangle, like Brittany said. What are the 2 and the 3 representing in this rectangle? What are the 2 and the 3 representing? Paloma? The sides, or the dimensions, right? We also call them the factors. The factors. Because aren't factors of 6, 2, and 3? Oh. What are other factors of 6? Aiden? Yeah, so can I do this? Isn't 6 a 1 by 6? Mm-hmm. So however many rectangles you make are also the factors. It's the area. Did the area change when I just did that? The area is still what? 6. But I changed the dimensions. I changed it to 1 by 6. Okay, let's look at the 2 by 3. Okay, so this is our area model, and it can always do the length times width. Is this the same rectangle? Did I change the dimensions? Did I change the dimensions? No. Not really. They're still 2 and 3, aren't they? Except now we say 3 by 2. But it's the exact same thing. Please don't get hung up on if it's turned sideways. That is not a different rectangle. That is the exact same rectangle. It's just rotated.
It's congruent.
It is congruent. Very good. It is congruent. Okay, so what happens if I do this? What did I do to it?
Then you get negative 6.
But what did I do to the area model? I want, what is this? What's another word for this right out here? I say negative, but what's another word for it? Opposite. It's the opposite of 2 times 3. Look up here for me, please. I'll wait till I see all eyes. Okay. I want the opposite of 2. So I want this direction. I want the opposite of 2. So what am I going to have to do to get the opposite going that way? You have to flip them all over. So start flipping them over until you get the opposite of 2 by 3. Okay? It starts out, the dimensions are 2 and 3, no matter how you want to look at it. But when you say the opposite of 2, when you start doing this, when you say it's the opposite of 2 times 3, that means the opposite all the way down. Every single one of them, not just one little pair. It's all the way. okay? It could be negative, however you want to think, but it's the opposite. So what would happen if I did this? It'd be what?
Same.
It's the same, isn't it? Because this time it would be the opposite of 3, so they would go opposite this direction. So it just takes from wherever the dimension is and changes everything going that way. So this opposite counts for everything going down at that entire dimension. I think I know where your question is going to lead me, but go ahead, Brittany.
If it's in the negatives, and then it obviously means that it's 0 because it's the way it's in there. How would, because usually 0 times 2 is 0.
True.
So how would negative 3 times 2 be?
Because we want the opposite of 2 sets of 3. See how when I change the words in your head, I want the opposite of 2 sets of 3, or I want the opposite of 2, okay, or I want negative 2 sets of 3.
So it's just the exact same thing.
You're trying to think of it as a location in space, like a location on a number line, and that's where it starts to get really kind of confusing. But in essence, if I do the location on the number line, here's 0. If I want to go 3 sets of negative 2, 1, 2, 3, I'm here at negative 6.
Was my question what you thought it was going to be?
No, but it was a great question. Chrissy.
What if both of them were negative?
That's the question I thought was coming. That was a great question. Okay, so let's take a look at what happens if you have negative 2 times negative 3. Okay, well, first of all, we know what negative 2 times 3 is, right? That turned them all over. What happens now if I now want to make this one negative? So it is. It's the opposite of negative 6. Or now it's the opposite going this way. What do you have to do? Flip them all back over again because you want the opposite this way. Whoa. Now they're flipping over again. Every time you say the opposite of, what do you need to do to the tiles? Flip them. So this way, flipped them over once red. This one flipped them back over again yellow. So the answer is going to be positive 6. The opposite of the opposite, or the opposite of negative, is positive. So if you use the words opposite, it really helps. The opposite of negative is positive. On the back, all of it's about multiplying and right now, and I will show you dividing in a minute, but can you look on that note maker where it says pictures, draw a picture using multiplying, so you're going to have to change them to opposite. I'll be right with you, Reed, okay? And then at the top it says describe why we use an area model to show multiplication. It's tangible. It's something you can talk about. The area model uses a rectangle. It talks about dimensions and factors. That's everything we know about multiplication. That's why a little square works. One of you guys noticed right at the beginning they were squares. There's a reason for that, so we can use area. Okay, so we can do 2 times 3 is 2 sets of 3, or it's a rectangle. Read, question?
Do the same, here's an easy way to remember it.
Okay.
Do the same is positive, 2 that are different, negative.
They're always going to be negative, yeah. That's true. Zach?
I think I figured out how these are going to divide.
You did. Oh, good. Hold that real quick. Fill out your multiplying, and then I'm going to ask you right off. No, like right here in this corner, right there. To show that it becomes a rectangle. 2 times 3 becomes a rectangle of 6. You might want to do ones where you have like negative 2 and 3, and what that does, it turns the whole row opposite. What does divided by mean? It's a great question. I ask this to adults sometimes, and they look at me stunned with that question. What does divided by mean? Dylan?
Split into groups.
Split into groups. Why can't adults figure that one out? That scares me. It's not only split into groups, it's split into what kind of groups? Hayden? Almost. Factors is exactly where division comes from. Split into what kind of groups? Zach?
They're split into groups of the amount of what you're dividing whenever you're dividing by.
That's true, because they have to be split into equal groups. The groups have to be equal. So when you do division, you have to think of it as like when you babysit little kids and you have 2 of them and you pour them milk and you give one kid this much milk and another kid this much milk. What do the kids do? He has more than me! And then you can like pour this one out and they're fine. That's what division is. Division is in equal exact groups. So if I say 6 divided by 2 in tiles, what would that look like? What would that look like, 6 into 2? Elizabeth, go ahead. Sure, let's do it up here. Okay, she's going to show me 6 divided into 2 equal piles, because we said it has to be equal. Shh, you guys are chatty over there. There's 6 total, and now she needs to split them into 2 equal piles, which would be what she pretty much has, but she's going to separate them more into 3. Are we okay with that? You okay with that with tiles? So I could ask you any tile division as long as you can do it without an X-Acto knife. You'd be okay, right? Okay. Thank you, Elizabeth. Good job. Then what would this be? Oh, I'm going to write division a little different. Are you okay with that? You okay with the symbol? All right. -6 divided by 2. What would that look like? I want you to see if you can start tiling it. I'm going to look around and see if I can see anyone tiling that. That means you can't be tiling something else. You need to be tiling that.
I think I got it.
Ooh. See, Kaylin got it. I don't see it yet, James.
What? I wasn't looking. I got it.
Divided by 2.
All right, I got it.
Good. I see Brady's got it too. Brady, what did you put up there first? Mm-hmm. Brady put 6 reds up. Did we agree?
Yeah.
Okay. And then what did you have to do? Or 2 equal piles, right? Okay. So what's your answer going to be? What am I looking at? What's my answer? Bryson? Is it +3? Are these in 3 yellows? Yeah, that's right. It's going to be -3. You have to look at what color you've got right there. Yes, ma'am?
Are you going to be here after recess too?
I don't know. We haven't totally discussed that at the moment. I think you guys have lunch, don't you?
Yes.
Okay. What would this look like? Uh-oh. This one looks different. What would this one look like?
Oh boy.
What would you start with? Let's talk about it. What would you start with? 6 yellow, right? 2, 4, 6 yellow. And we want to divide it into what? Into negative, or the opposite of 2 piles. So what are we going to have to do to these? We'll put them in 2 piles, and then we're going to have to, what? I heard it. Flip them. They have to be flipped over. So you're going to have to flip them all over because you want the opposite of 2 piles. So what is your answer? -3. Does it matter where your negative sign was? Top or bottom? No, you got the same answer. So I think that Brittany's going to ask me, what question are you going to ask me?
I'm going to ask you what if both of them are negative?
Ah, like this. What happens if you start with -6 and you want the opposite of them into, oh, I'm going to put them in 3 piles. Yeah, first I want them into 3 piles, but then I want them in the opposite of 3 piles. So what had to happen? Got to flip them all over. So what's my answer going to be? What is my answer going to be? How many are in each pile?
2.
+2. So what happens when you have 2 negatives? Opposite of the opposite is, the opposite of negative is? Positive. Yeah, the opposite of negative is positive. That's really, are we okay with the area model? It's a little bit easier than the adding and subtracting, isn't it? It's just like, well, it's opposite, turn them all opposite. If it's opposite again, turn them all back. It's all about flipping it around, okay? Would you explain that to yourself at the very bottom of the page? There's dividing on there if you want to fill in some dividing, but it's just putting them in separate piles. Good job, Reed. It's putting them into separate piles, dividing integers. No different than multiplying. It's just you're looking for the dimensions.
Hard to do in words.
It is hard to do in words, but you can say it in words and you really know what you're doing. Across the top column so we know what we're doing so you can get done and be done. Just pack up your algebra tiles and leave them on your desk. I'll come around and get to them. Don't worry about it, sweetie. Just put in what I swear, they are an amazing creature that can disappear faster than anything in the world. Sit down, please, and let's figure out how we're doing this. Orlando, I need you with me. Brittany. First of all, you have to put your name. And no, you can't use me. That's me. This is our, can you add and subtract integers using algebra tiles? That's our goal today. If I look at the first column, A plus B, the A and B are over here. So what I mean by that is I would just do 4 plus 9, because that's what A and B were. Draw a model of that. That's pretty simple. We have our 1, 2, 3, 4, and then our 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 3, 4, 5, 6, 7, 8, 9. That's how it would look as a model. You can do pluses and minuses too. Write another problem that gets me that same answer. So what is that answer? Right? What's another problem that can get me to 13? Thank you. 6 plus 7. Now, A minus B. That means it's 4 minus 9. Notice I didn't switch them around. I left A first and then B. Write it as an addition problem. We do that as 4 plus negative 9. Because that's the same thing, right? And you can leave it as 4 minus 9 if you'd like. That's fine. What is 4 minus 9 or 4 plus negative 9? What is that answer? Well, let's draw a model just to make sure. We have 4 positives, 9 negatives, I know, I made them circles. And what happens with our pluses and minuses? What is that called? A plus 1 and a minus 1? Additive inverse. Very good. So we're going to get rid of our additive inverses. And what do we have left? Oh, 1, 2, 3, 4, 5, negative 5. Notice different signs. The biggest one was 9. It becomes negative 5 and 9. And we'll write another problem that gets to a negative 5. Can someone find one that gets me to a negative 5? Ben? 3 minus 8 gives me negative 5. Excellent.